मैथमेटिकल इंडक्शन। 11th क्लास में हमने मैथमेटिकल इंडक्शन का चैप्टर पढ़ा है, उसी के बेसिस पे हम क्वेश्चन सॉल्व करेंगे। प्रूव द फॉलोइंग मैट्रिक्स बाय यूजिंग मैथमेटिकल इंडक्शन। इफ a is equals to 3 minus 4 1 minus 1 then an is equals to this। मैथमेटिकल इंडक्शन में हम क्या करते थे, 3 स्टेप्स होते थे। फर्स्ट स्टेप में हम प्रूफ करते थे कि रिजल्ट इज ट्रू फॉर n is equals to 1। सेकेंड स्टेप में हम एज्यूम करते थे कि रिजल्ट इज ट्रू फॉर n is equals to m। एंड थर्ड स्टेप में हमें प्रूफ करना है कि रिजल्ट इज ट्रू फॉर n is equals to m plus 1। लेट put n is equals to 1, an instead of n put 1 here, 2 into 1, 4 into 1, 2 into 1, 3 minus 4 1 minus 1, that is this is the matrix A. So result is true for n is equals to 1. Result is true for n is equals to 1. Second step में let us assume that result is true for n is equals to m, then am is equals to 1 plus 2m minus 4m m 1 minus 2m। थर्ड स्टेप में हमें प्रूफ करना है रिजल्ट इज ट्रू फॉर n is equals to m plus 1, am plus 1 1 plus 2 into m plus 1 m plus 1 minus 4 into m plus 1 1 minus 2 into m plus 1। ये हमें प्रूफ करना है। am plus 1 we can write it as am into a am plus 1 is equals to am into a. What is the value of am? 1 plus 2m minus 4m m 1 minus 2m. So what is the value of a? 3 minus 4 1 minus 1. Now multiply these two matrices. 3 into 1 plus 2m minus 4m into 1, 3 into m, 1 into 1 minus 2m, minus 4 into this, minus 4, minus minus plus 4m, m into minus 4, minus 1, minus minus plus 2m. Now solve this. 3 plus 2m, 3 plus 2m minus 4 minus 4m m plus 1 minus 2m minus 1. Now we can write 3 as 1 plus 2, taking 2 common, m plus 1 minus 4 common, 1 minus 2 into m plus 1. Check it. 2m, 2 plus 1 3, 3 plus 2m minus 4m minus 4 m plus 1, 1 minus 2m minus 2 plus 1 minus 1. So therefore the result is true for n is equals to m plus 1. Hence the result is true for all positive integers n by principle of mathematical induction. Now the next one is question number 2. If a alpha is equals to cos alpha sin alpha minus sin alpha cos alpha, then prove that a alpha into a beta is equals to a of alpha plus beta. Second part is a alpha power n is equals to cos of n alpha sin n alpha minus sin n alpha cos of n alpha for every positive integer n. A alpha is this, into cos of beta sin beta minus sin beta cos beta. Now multiply these matrices. Cos alpha into cos beta, sin alpha into sin beta minus sin alpha cos beta minus cos alpha sin beta cos alpha into sin beta plus sin alpha cos beta minus sin alpha sin beta plus cos alpha cos beta. Now we have formula cos A minus B, cos A plus B. Cos A plus B is cos A cos B minus sin A sin B. So that is equals to cos A plus B. Taking negative sign common, cos A sin B plus sin A cos B, that is equals to sin A plus B, sin alpha plus beta. Cos A sin B plus sin A cos B, sin A plus B. Cos A cos B minus sin A sin B, cos A plus B. That is equals to A of alpha plus beta. Instead of alpha, if we put alpha plus beta here, then A of alpha plus beta is cos of alpha plus beta sin of alpha plus beta minus sin of alpha plus beta cos of alpha plus beta. Now second part is, we have to prove the second part by using mathematical induction. Put n is equals to 1, A alpha, n is 1, so cos alpha sin alpha minus sin alpha cos alpha, that is equals to A of alpha. So result is true for n is equals to 1. Let us assume that result is true for n is equals to m. A alpha m is cos of m alpha sin of m alpha minus sin of m alpha cos of m alpha. Now we have to prove that result is true for n is equals to m plus 1. Instead of m plus 1, cos m plus 1 alpha sin m plus 1 alpha minus sin of m plus 1 alpha cos of m plus 1 alpha. Now A alpha m plus 1 is equals to A alpha m plus 1 is equals to A alpha m into A alpha. A alpha m is cos of m alpha sin of m alpha minus sin of m alpha cos of m alpha. A alpha is cos alpha sin alpha minus sin of alpha cos of alpha. Multiply these two matrices. Cos m alpha cos alpha minus sin alpha sin m alpha minus sin m alpha cos alpha minus cos m alpha sin alpha cos of m alpha sin alpha plus sin m alpha cos alpha minus sin m alpha sin alpha plus cos m alpha cos alpha. Again we will use the same formula. Cos of A minus B is equals to cos A cos B minus sin A sin B, that is equals to cos of A plus B. Minus common, taking negative sign common, cos A sin B plus sin A cos B sin A plus B cos B, sin A plus B, cos A cos B minus sin A sin B, cos A plus B. Taking alpha common, but we will get cos of m plus 1 into alpha minus sin of m plus 1 into alpha, sin m plus 1 into alpha, cos m plus 1 into alpha, that is equals to a alpha power m plus 1. Therefore, the result is true for n is equals to m plus 1. Hence, the result is true for all positive integers by using mathematical induction. Now the next one is if A is non-zero real or complex number, use the principle of mathematical induction to prove that if A is equals to A1 0 A, then an is equals to an minus 1, 0, an for every positive integer n. First step, put n is equals to 1. A1 is, so that is equals to A 1 minus 1 is 0, 0 A. Something power 0 is 1, so A1 0 A. So that is equals to A. So the result is true for n is equals to 1. Let us assume that result is true for n is equals to m. M minus 1 0 A m. Now we have to prove that result is true for n is equals to m plus 1, a m plus 1, m plus 1, a m plus 1 minus 1, 0 a m plus 1. Now a m plus 1 is equals to am into a. am plus 1 am into a. Am is am m minus 1 0 am a 1 0 a. A is a1 0 a. Now multiply these matrices. A into am plus this into 0, 0 into a plus am into 0. Am into 1, a into m minus 1, 0 into 1, a into am. Now we know that if the base are same and they are in multiplication, then powers will be added. Base is same, a, so powers will add a m plus 1. Here a m plus 1. Take am common. What we get? 1 plus a power m is common. So a m minus 1. A power minus 1 means 1 upon a. So we can write it as a m plus 1. It will get cancelled. M plus 1 a m 0 a m plus 1. We have to write it in the form this. So here we add and subtract 1. A m plus 1 minus 1, it will remain a m. So that is equals to a m plus 1. So the result is true for n is equals to m plus 1. Hence result is true for ANI plus NA n minus 1 BA, where I is the unit matrix of order 2 and n is a positive integer. Now put n is equals to 1, AI plus BA, n is 1, A into identity matrix, that is A, 1 minus 1 is 0, something power 0 is 1, so AI plus BA. Therefore, the result is true for n is equals to 1. Let us assume that result is true for n is equals to m. AI plus BA, m is AMI plus MAM minus 1 BA. Now we have to prove that result is true for n is equals to m plus 1. AI plus BA power m plus 1 is equals to am plus 1I plus m plus 1 minus 1 BA. Now we know that AI plus BA m plus 1, we can write it as AI plus BA power m AI plus BA. What is the value of this? AM into I plus MAM minus 1 BA into AI plus BA. Now multiply these matrices. Multiply the terms. AMI into AI plus MAM minus 1 BA into AI plus AMI into BA plus MAM minus 1 BA into BA. Now solve it. A base is same, add the powers. A m plus 1, I into I is I square, that is identity matrix I. M A m minus 1 plus 1 BA into I is BA. A m I into BA plus MAM minus 1 B square A square. Now find the value of A square. A is 0 1 0 0. So A square 0 1 0 0. Multiply 0 plus 0 0 plus 0. So A square is 0. Now put the value of A square here. Since A square is 0, so A m plus 1, A m plus 1 I, M A m plus 1 minus 1 BA plus AM BA plus 0. We can write this A power m as A m plus 1 minus 1. So AM plus 1 I, taking this term common, A m plus 1 minus 1 BA. Here we are left with m and here with 1. So m plus 1. So this is equals to AI plus BA power m plus 1. Therefore, the result is true for n is equals to m plus 1. Hence, result is true for all positive integers n. Now the next one is question number 5. If A is equals to 1, 1, 1, then prove that A power n 3n minus 1 3n minus 1